Morning, welcome back. Today we will discuss a new type of projection called isometric projection. So before going into the detail, let us have a quick look over the projections that we have already studied. The first type of projection that we have studied is orthographic projection. What is orthographic projection? It is a projection of a point or a line or a plane or an object on two mutually perpendicular planes. Which may be vertical plane, horizontal plane, profile plane like this. But what is the major disadvantage, limitation of orthographic projection? We will be able to mark only two dimensions of the object while drawing the orthographic projections. You know that basically there are three dimensions for an object: length, breadth, and height. And naturally, we have to use three axes: x, y, and z axis. Conventionally, on x axis, we will be marking the length, y axis will mark the breadth, and z axis will mark the height of the object. So, in orthographic projection, the angle between the axes is 90 degrees. For example, if we take the square prism, okay, while drawing the front view of this object, we will be able to mark the length and the height of the object. While drawing the top view, we will be able to mark only length and breadth of the object. Whereas when we draw the side view, we will be able to mark the breadth and height of the object. See, we will be using XOZ plane while drawing the orthographic projection of a square prism. So we mark the length on the x-axis, height on the z-axis, and drawing the top view, length on x-axis, breadth on y-axis. Whereas from the side view, we are marking the breadth and height of the object. Okay. So what is the difference between isometric projection and orthographic projection? So here we will be using three axes. This is the z-axis. I can say this is x-axis and this is y-axis. The angle between this becomes 90 degrees in orthographic projection. So I will be making some adjustment in orthographic projection, the axis that has been used in orthographic projection. Okay. So you can see that conventionally we will be using x, y, and z. What I have made is I will be changing this angle between x-axis and z-axis. Instead of 90 degree, increasing this angle to 120 degree. Okay. And the angle between the z-axis and y-axis, that is this angle, and increasing to 120 degree. Okay. So this angle is normally this angle will be also 120 degree. So we'll be using three axes, but the angle between the axes are 120 degree in isometric projection. Okay. Whereas the angle between the axes are 90 degree in orthographic projection. Okay. So we'll be using three axes. In isometric projection, these axes are called as isometric axis. This is called as isometric axis. Okay. So while drawing the orthographic projection, you can see that this angle is 90 degree, so this becomes 45 degree. Okay. So how will you convert or transform this orthographic projection to isometric projection? So we have to keep in mind that this angle should be 120 degree in isometric projection, not 90 degree. Here I am making a slight adjustment. Okay. I will be extending this to this side. So the x-axis will come here and extending this axis, y-axis, to this side. Okay. Then you can see that Still this angle is, so I'm extending this. So this angle will be the same 120 degree. Angle between y-axis and z-axis is 120 degree. So this angle now becomes 180 minus 120 by 2. So this angle becomes 30 degree. This angle becomes 30 degree. What is the advantage of changing the axis like this? See, I will making the angle 120 degree by drawing two 30 degree lines. One line represents the x-axis, the second line will represent y-axis, this vertical line will now represent the z-axis. So I can mark the length of the object here, breadth of the object on y-axis, height of the object on z-axis. Okay, so now my isometric axis becomes like this. So I will be marking the length here, breadth here, then height along this axis. So I can draw two planes. Each angle is, this angle is 120 degree. What is the advantage of this figure? We will be able to mark the two dimensions of the object in a plane, single plane. Okay, sorry, not two dimensions. We will be able to mark the three dimensions of the object in a single plane. See, we are marking length, breadth, and height on a single plane. On a 2D plane, I can say that it's a 2D plane. So if you draw parallel lines, this like this. So I'm drawing a 3D object in a 2D plane. So you can see that this angle is 120 degree. So in isometric projection, the angle between the vertical faces will be always 120 degree. Whereas in in orthographic projection, the angle between the vertical face will always 90 degree. Okay. Now, what are the changes that has been taking place when you convert this angle from 90 degree to 120 degree? So you can change the angle like this, slightly compress the solid. So you can see that the angle becomes 120 degree. So what are the changes taking place when you convert an orthographic projection into isometric projection, or converting this angle from 90 degree to 120 degree?